This podcast is sponsored by RaterExamPrep.com, my own personalized, interactive guidance through anyone challenging a ResNet exam or for HERS raters getting recertified. More at RaterExamPrep.com. Enjoy. Welcome to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford. Today we're talking about trends in high-performance building and retrofits with Brian Christensen, who is a senior engineer at Architectural Energy Corporation. He's one of the people who designs REM rate, or REM design, which many of the HERS raters across the country use. Brian, thank you very much for being on the show.
My pleasure.
So let's just jump to the heart of it. What is the problem with energy modeling?
Oh, well, I would say that the problem with energy modeling is that too many people think that it is the absolute truth instead of a representation of reality.
And how close can we get to reality? Is it like feasibly close or close enough for, obviously it's close enough for rebates and incentives from the federal government. Should that be good enough in general, just that the assumptions that we're making are fine for moving forward as we get tighter and tighter and, houses become more and more inflexible?
A bunch of thoughts popped in my head as you were asking the question. I think the key thing with residential energy modeling is to not get too uptight about getting it perfect. In part, you just have to get a sense of what things are the most important. And probably the best way to do that, we've got a tool in REM which allows you to get a sense of that. If you look at the component consumption graphic for any building that you model, you can actually see which things seem to be the biggest energy users. And those are the things probably where you want to focus your efforts at modeling relatively accurately so that you can get a sense of how much you can really improve them and do an accurate job of improving them.
What about commercial energy modeling, which is a completely different thing?
For commercial projects, you definitely do not want to use REM. REM is actually designed purely for residential purposes. But the tools like Energy Plus is a really elaborate tool, but I think most people use, and I'm blanking on it, it's a variant on Do2.
And you come to this as a physicist, is that right?
Well, my bachelor's is in physics, but I also come at it, I went into mechanical engineering for my master's because I wanted to do something pragmatic. I wasn't really interested in so much in the research side of things. There's a part of me that wishes I would do research, but I really like to see where the rubber hits the road, that we actually get things done in the real world.
Is that the part of you that the small part of you that was interested in research that sent you to Antarctica?
Antarctica was an opportunity that came up that it was an opportunity for adventure. And, right out of college, what better time to go off and take a great adventure like that when there's not anybody depending on you and so on. I had a chance to see just amazing phenomena. I got a chance to see the wildlife in Antarctica. I got a chance to see astronomical phenomena that you just don't normally get to see. I got to live, and I was there for a full year. It was a great experience.
So speaking of going around the world, it was mentioned to me recently in talking about commercial energy modeling for multifamily buildings, which you and I both work on, that energy modeling for those buildings actually does not require a local person to do. And nowadays, India is such a huge part of the computer programming world that you might as well just pay somebody in India to do it for however many cents a square foot, which is probably half as expensive as it would be to get an American mechanical engineering firm who really, has to a much higher cost of doing business and everything. What do you think is going to, do you see that as a trend going down the road with even any kind of energy modeling?
I think it depends on what the energy modeling is for. In the context that we've been just talking about right here with the multifamily, quite often the multifamily energy modeling is being done, and we're talking bigger buildings, like mid-rise buildings, I'm assuming, because we're talking like Do2 type models. REM is simple enough, you don't need to send it overseas to have someone do the model. But in the context, for example, of a Lead for Homes mid-rise project, there is a real benefit to having people within the same company working together on the modeling and other aspects of the rating system. Because you really need to look at the plans and kind of spot issues, and you need to be able to communicate that efficiently to the modeler. The modeler might spot it, then pass it on to the verification team. And so there's synergies that come about by having those people in the same place. If you've got an organization that has enough depth in it that you can actually do the modeling and do the verification work internally.
What do you see coming down the pike in the next couple of years in either the residential, single-family, or multifamily fields?
Well, yeah, in the context of REM, I guess I'll narrow it down to that, because that's really more where my knowledge base is in terms of modeling. I find it very interesting, the ideas going on right now of actually possibly using REM as a verification method for IECC codes. Or not, I shouldn't say REM, but ratings, HERS ratings as a verification for IECC code. That actually might make life a lot easier for us on the REM team, because then we don't actually have to work so hard to implement the IECC code. It's kind of implicit already in REM. But the fact that the codes are getting more stringent, that I think what's going to be interesting is actually dealing with the fact that we're going to be hitting points of diminishing returns. Already, when you have a more energy efficient single-family home, you run into much the same problem you have with apartments that are not necessarily as efficient in terms of their envelope, but you have what I'm trying to say is lights and appliances start to really become a much more significant part of the energy consumption of the building. And so we're kind of having to shift our focus, and it's not so much being driven by the envelope at that point, but we have to start looking at these other things, like what is our choice for refrigerator, what is our choice for dishwasher, washing machine, what kind of synergies do we start looking at in terms of providing our domestic hot water and our space heating, because as you drive the space heating loads way down, you're starting to get down in the range where it might make a lot more sense to have the same device do both things. And then you run into other issues like competition for, anyone who's lived in an apartment that has a fan coil unit that's running off a hot water heater has possibly had the experience of getting in the shower in the morning when the thermostat just got set up. And so it's calling for heat at the same time as it's trying to provide enough hot water. And sometimes one of them runs a little short. So there's going to be some interesting technical problems to resolve there. And I think the Building America program is addressing some of those through TOE.
And they've just released a new online tool that I was talking with Sam Rashkin about on this show. So one of the things that you just mentioned is actually really interesting to me. You said that the lights and appliances will start to matter more soon because we're getting the envelope and the mechanical system sized, more in a more controlled manner. And interestingly, so in Chicago, we had Best Buy starting to give energy audits, which a lot of us in the local market thought was crazy because you can't have employees at a big box store be building scientists. That's not a great fit. However, what's interesting is that if those companies, the big box stores and the electronics stores, were encouraging and marketing for home performance, at the end of all this improvement, now they have actually created customers, because once the envelope in the HVAC system is taken care of, the only thing that matters, in fact, is the refrigerator and the washing machine and the dryer and the TVs and lights. That's pretty interesting.
Yeah, if it may not prove to be the only thing that matters, because certainly the more our little wall cubes proliferate for recharging our iPhones and our laptops and all of our other various devices, we have lots of parasitic loads just in terms of our plug loads. And that's a big frontier that no one's really addressing yet. And I suspect, there's certainly frontiers in terms of the energy modeling that have not been addressed that are going to become more important.
Interesting.
The equivalence of any place where people are running hot tubs and stuff like that, we may have to start paying attention to how we're dealing with the plug loads, various other electrical loads.
It seems like Americans are probably fighting with you in our need to have constant access instantaneously to anything in the house and have it be ready to be on at any moment.
Yes, and I think I think we need to ask ourselves that question as a culture is how important is all that kind of access to us relative to the impact that that has on our climate because of the way we use energy. We're certainly seeing the real effects of climate changing, and whether or not you believe that humankind was a major factor in that climate change or not, the evidence is clear that our activities do have an impact on climate to some degree, and we can exacerbate the problem or not. We're going to have to face that sometime in the next couple of decades, and we'll see more interesting weather events that'll probably prompt us to pay better attention.
Yeah. Now, when I talked with your partner Rob Salcido on this show, he had mentioned that the REM engine itself hasn't actually changed much in decades. It's a pretty solid, rock solid kind of bit of programming. And I recently was looking at the Home Energy Score software. So it seems like a lot of the softwares, no matter what you're using, all of them, in order to not turn into a completely ridiculously anal process that a PhD would have to fill out, you have to make assumptions.
Oh, yeah.
What is the ratio of the assumptions that you have to make for new homes versus old homes, and for tighter homes versus looser homes? How does that work out? Because you're the one actually behind the curtain pulling the levers.
That is a great question, and particularly in the realm of existing homes, nobody has a real good answer yet. There's some real efforts being done by DOE, particularly at NREL, to try to untangle why it is that all of the modeling softwares tend to overpredict the energy consumption on the less efficient existing homes. The tools work really quite well for efficient homes, and there's lots of speculation as to various reasons why. Various people have different pet theories, and probably there's a little bit of truth in many of them. I can read code, but I'm not a real programmer. I am really good at finding bugs. I think it's because I have lots of experience as being a user. I am a HERS rater. I was a HERS rater for 8 years before I joined AEC. I used REM in the field. And I know what it's like to be a small business owner trying to use REM. And I apply that information and represent that information to the rest of the REM team. And that is part of what my value is as in the team in terms of guiding the ongoing development of REM. We're doing more research. Rob and I are part of a couple of working groups actually, that are trying to address this issue, particularly in the context of calibrating the models, which is really the best way we have to try to get the existing home issues worked out, so the models actually do a better job of saying, this is how much we think you actually used, and when you compare that to the utility bills that have been normalized to your weather, that you actually see a pretty good match. That alignment of the model with the actual building and actual utility bills is really quite important before you actually try to predict the benefit of improvements. And that's a big challenge.
Interesting. How important is real historic weather data versus averages in energy modeling?
Well, it depends on what you're trying to accomplish. REM takes real weather data for the purposes of the utility bill disaggregation part of the tool. And the purpose of that is to say, okay, you've got...
And that's what you just referred to as calibrating, right?
That's a key part of the calibration opportunity that is within REM. You need real historical data for the weather to match up with the real historical usage patterns, because some years are going to be, have more demand for heating, some years are going to have demand for less, and you want to make sure that aligns up pretty well. A lot of people will compare their REM model to an actual set of utility bills and say, wow, there's a big mismatch here. There's lots of things that could be affecting that, but first and foremost is the fact is they're using a specific year's weather while the model is using a 30-year average either TMY2 or TMY3 type weather.
Back to existing homes. So we've got this conundrum in the U.S. that's called the energy efficient mortgage or the energy improvement mortgage. And I have been involved in one or two of these things, and I do not enjoy the process. The first time that I was doing it, I had a little house that had no insulation in the attic. It was like 2 inches maybe that was spotty. And I was trying to tell the computer that what I'm going to do is take 2 inches of insulation, I'm going to turn it into 12 inches of insulation, which is what you could fit into this little tiny roof cavity. And it insisted that it would not pay off over 30 years. So I called my mentor, and he said, who will remain unnamed, he was great, and he said, well, you have to kind of finesse the software. No, finesse is not what I mean. Better to say manipulate. So when I'm dealing with these existing homes where what the software and the reality are dealing with are two different things, and I understand that the working groups are working on this, how do people right now sleep with the fact that they have to manipulate the software to get it to do a more realistic approach to older homes, which we don't quite understand yet?
There's a whole lot of questions packed into that one that you just
I apologize.
gave to me. Well, no, that's quite all right. There's a philosophical one, and let me hit that one first, and I'll try to remember the other one so I can come back to it. The philosophical question is, how do you sleep with it? I think it's very important to remember that an energy model is a model of reality. It is not reality itself, and it's inherently an approximation. It's a judgment call as to how close you have to get in order to make whatever decision it is you're trying to make. And, that's got to be done on a case-by-case basis. So I think that just comes down to getting as much experience as you can, talking to lots of experienced people, talking to other smart people that can help you puzzle out what is a good choice to make in a given situation. But to step back from the philosophical question, there's a process. In the specific example you gave of actually seeing an obvious lack of insulation in the attic, it may be that particular house had a bigger energy loss somewhere else. And that by adding the insulation in the attic, you're putting a patch on something that was already patched well enough as far as how the house was currently performing. And that's why when I recommend a process for people to deal with existing homes when they're doing REM, I say, all right, first of all, you start off with your utility bill, get that information in, build your model based on your audit, do your calibration as best as you can, and that's part art and part educated guesswork. The next step, which I think is really important and a lot of people don't really think about doing, is run some of these reports that REM has that break down the energy use by different components of the building. So I like to look at the component consumption report, particularly the graphic, because the graphic makes it real obvious to you how much energy. You see certain bars sticking way above all the rest. You go, oh, look at that.
My window U value is 3 instead of 0.3.
Or my infiltration is blowing everything else out of the water. And until I take care of that, anything else I do isn't going to make a darn bit of difference in how much energy my building uses. So it's really important to look for where the areas are that you're really losing energy. And once you've got your model, once it's reasonably calibrated, the component consumption graphic, I think, is a great way to give you a sense of where to direct your attention as far as your first priority improvements. Mm-hmm. And that will get borne out when you do the improvement analysis, which is an economic optimization.
What are you excited about over the next couple of years in the building industry?
I am excited by the prospect of actually bringing the multifamily market kind of up to the same level that the single-family market did in terms of being able to perform and build a really good enclosure and compartmentalize the units and make sure they actually have fresh air systems in them, which is one of the things that Lead for Homes pushes and Enterprise Green Communities push. Those are things that the multifamily market has never really cared much about and hasn't really thought was necessary. But, for those of us that have lived in apartments from time to time, that when you get into the inner part of an apartment, opening the window to try to get the air so it's not stale on the backside of the apartment doesn't really work unless you happen to open the door as well.
Right. Brian, thank you very much for being on the show.
My pleasure.
Brian Christensen is a senior engineer at Architectural Energy Corporation and REM Rate. You've been listening to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford. Tune in next time.